The topics for today is measure of dispersion. That's section 12.3, the measure of dispersion. And in the previous section, we mentioned measure of central tendency. This is the measure of dispersion. In this measure of dispersion, we do three things. Okay, measure of dispersion. We do range of the data, range. Number two, deviation. Actually deviation from mean. Okay, deviation from mean. And we do standard deviation, STANDARD, standard deviation. Therefore, in this section, measure of dispersion, we do three things here: range, deviation, and standard deviation. And we do each one with the examples from the homework. We use homework question for the example. Okay, let's start with the range here. If you have a data set, what's the range of the data set? Okay, let's talk about the range first. RANGE, range. Remember that range is also dispersion. Again, these all three are dispersion: range, deviation, standard deviation are the dispersion. I explain you what do we mean by range, deviation, standard deviation. Let's start with the range here. The range is in the data set the difference between the highest and the lowest data values. The highest and the lowest data value is called range. Okay, it's called range. Therefore, to find the range, you just subtract highest data value minus smallest data value. And question number one is about find the range of the group of the data item. You have how many data item here? You have 1, 2, 3, 4 data item. We call as n equals to 4, but I don't have to say it. But largest data item here is 15. Smallest data item is 8. Therefore, range here equals to 15 minus 8. Okay, and you subtract that, you get 7. That's the range. Range is 7 here. You guys see what I'm saying here? Range is 7. That's all. Pretty simple, right? The question number 2 is about find the deviation from the mean for each of the data item. Therefore, next measure of dispersion is going to be deviation from the mean. Okay, the data are given here. There is how many data here? 18, 30, 42, 72, 108, 162. Okay, that's the data. The mean of the data is 72. You don't have to find it. The mean is given. And the first question is find the deviation from the mean for each of the data item. Therefore, in other words, 18 is how far from the mean. That's called deviation from the mean. What you have to do is you subtract data minus mean. Data minus mean. That's how you do find the deviation. Okay, deviation. Deviation can be found using the formula data minus mean. For example, for 18, what's the 18 minus 72? You subtract that. 18 minus 72 is negative 54. Therefore, here for 18, deviation is negative 54. Similarly, for 30, what's the deviation? You do the same thing. 30 minus 72. Always you subtract data minus mean. Look at this is the formula for deviation. Data minus mean. So you have a data, 18 data, 30 data, 42 data. You subtract each data from each data and mean. Okay, what is 30 minus 72? Is going to be negative 42. That's the deviation. And similarly, what's the deviation of 42? 42 minus 72, which gives you negative 30. That's the deviation. And what's the deviation of 72? 72 minus 72, which is going to be 0. 0 is the deviation. What's the deviation of 108? 108 minus 72. Remember that always data minus the mean, which is going to be 36. And finally, 162 deviation is 162 minus 72. That gives you 90. Okay, therefore deviation from the mean is for 162 is 90. That's the first part of the question. Find the deviation from the mean for each of the data item. For we found the deviation for each of the data item. That's the deviation here. You can see that that's the deviation from each of the data item. And what's the question? Next question is part B, the sum of all deviation. What do you mean by that here is you find the deviation, you add all the deviation. What's the answer? For example, you add negative 54 plus negative 42 plus negative 30 plus 0 plus 36 plus 90. What do you guys think if you add it? This is going to be, let's say, going to be 0. Okay, if you add, the sum going to be 0. Therefore, in this case, deviation from the mean is the sum of the deviation in part A is 0. Is everybody sounds okay so far? Okay. All right. I found the measure of dispersion, which is range. I found the range, and I found the deviation from the mean. That's the question number 2. Right now, next question is find the standard deviation. Okay, and that's pretty longer, and pretty much other questions here are all about finding standard deviation. Okay, that's the other part here. And let's talk about the standard deviation a little bit, and I'll do the problem. Okay, standard deviation. There is a way to find the standard deviation, and step-by-step process, and using the formula at the end. Okay, standard deviation. Let me write down here. Standard deviation can be found by determining how much each data item differ from the mean. In other words, standard deviation measure how far the data spread around the mean. That means the dispersion is about spreading of data, like, scatter of the data. Sometimes the data are clustered around the mean. Sometimes data are all over the places. Therefore, sometimes data are away from the mean. By the time dispersion going to be more, standard deviation going to be more. In other words, if data are together like a pile towards the mean, close to the mean, that's the standard deviation is going to be less. But if the data are spread around everywhere in the data set, in other words, if the data are away from the mean, the standard deviation is going to be more. Therefore, standard deviation can be found by determining how much each data differ from the mean. Differ means mean to standard deviation, mean to the data, how far. That's the way you can determine the standard deviation. And I want to show you how to find the standard deviation of maybe a couple of questions here. Question number 3, 4, 5, all are the pretty much standard deviation, okay? But I'm going to do, let's do question number 4, because 3 and 4 are similar. Even 3 are few data, 4 are a little more data. Let's do question number 4, find the standard deviation for question number 4, okay? Let me write down the data here. Question number 4. The data are going to be 17, 17, and 17, 19, 21, 21, 21, okay? How many data here? You have 1, 2, 3, 4, 5, 6, 7 data. 1, 2, 3, 4, 5, 6, 7 data, okay? Therefore we call here n equals to 7, because number of data item is 7. Okay, now to find the standard deviation, you got to find the mean first. Find mean, because the mean is the way you determine the standard deviation, because standard deviation can be found by determining how much each data item differ from the mean. Therefore I'm looking for mean first. Okay, what's the mean here? Remember that this is the symbol for mean, x bar. We use x bar as a mean here. We can write MEAN for mean, but symbol is better. How do you find symbol? Mean 17 plus 17 plus 17 plus 19 plus 21 plus 21 plus 21 divided by 7. Okay, I put in the calculator, and you guys put that by yourself, and let's see your answer match with me, and we do further. Okay, can you type? Somebody help me to put that in the calculator and divide by 7. What do you get? Oh, I get 133 divided by 7, which is 19. Okay, do you guys have 19 as well? Okay. Okay, yes. Then thank you. Then that's the first step to find the mean. Now I got to find the deviation. That's what we did last time. To find the standard deviation, you got to find the deviation first. Therefore, let's find the deviation of each data. What I'm going to do is this. I'm going to put this data as like vertically like this. Let's put here. This is the data. Remember that I put x as a data. Okay, x as a data. Remember that in the last section I just mentioned the data is x. Data is x. 17, 17, 17, 19, 19, 21, 21. Okay, these are the data. All right, that's the data. Okay, now next column I got to find the deviation. What's the deviation? Data minus mean. Notice that data minus mean, the deviation. Do you guys notice the deviation? How do you find the deviation before? Look at here. Deviation is data minus mean. Data is x minus x bar. That's the mean. Therefore, let's find the deviation for each data item. What is 17 minus 19? Negative 2. Okay, 17 minus 19, negative 2. 17 minus 19, negative 2. 19 minus 19, 0. 21 minus 19, 2. 21 minus 19, 2. All right, okay. I forgot another 21 here. Because you have 321 here, but I only put 2. And I got another 21. Again, 21 minus 19 is 2. And next column, what you have to do is you square the deviation, okay? And negative 2 square is 4. Negative 2 square is 4. Negative 2 square is 4. 0 square is 0. 2 square is 4. 2 square is 4. And 2 square is 4. Okay, that's the next step. Now you add all the deviation square. Therefore, this is called sum. This is called sum. Sum of x minus x bar square, and that gives you now you have a 1 2 3 4 5 6, who's going to be 24, right? It's 24. Oh, 64, 24, 24. Now to find the standard deviation, we got to use the formula as I mentioned before. What's the formula? Standard deviation formula going to be, let me write down here, standard STD deviation deviation formula equals square root of sum of x minus x bar square divided by n minus 1. Again, this number, we found the sum before goes on the top of the fraction under the square root. Okay, you guys see here, this is called sum of x minus x bar square. That is, this number goes to the top. Therefore, it's going to be square root of 24 divided by n minus 1. And in this case, n is 7. Therefore, I put the 7 minus 1 in the bottom, which is going to be 24 divided by 6, which is going to be square root of 4, because 24 divided by 6 is 4, which is going to be 2. And really, standard deviation is 2. That's the answer. Okay, standard deviation is going to be 2. All right, that's not difficult to find the standard deviation. Rest all of the question is find the standard deviation, all, pretty much all. But I did one. Let's do question number 5. But notice that this does not have a data here as you see like this. But notice that this is the histogram, also bar graph, and to find the data for this diagram. Okay, here data are going to be this. You got to find the data from this graph. Remember that 7 is the data, 8 is the data, 9 is the data. 7, 8, 9. But notice that 7 has a frequency, this way of frequency. 7 has a frequency 1. Remember that. Look at this frequency axis. This is the 1, this is 3, this is the 4, this is the 7, right? You guys notice that's the frequency line. Therefore, 7 has a frequency 1. Therefore, 7 is one data value on the data set. How about 8? 8 has frequency 5. Listen, see, 8 has frequency 5, 4, 5, right? Therefore, what happens is it's going to be 8, 8, 8, 8, 8. The 5, 8 going to be here. And 9 has a frequency 1. 9 going to be here. That's the data. Okay. Therefore, what we did here is from this bar graph, we can figure out the data. Okay. Now, how do you find the standard deviation? As long as you have a data, you do exactly same thing we did before. Okay. First, find the mean. Can you guys find the mean? I'll do by myself and double check again. Therefore, mean here, x bar. Let me write x bar for the mean. Don't write MEAN. Just write x bar. 7 plus 8 plus 8. 8 plus 8 plus 8 plus 8 plus 9 divided by how many data here? You have 1, 2, 3, 4, 5, 6, 7. We call n equals to 7 here. 7 data here over 7. 156 divided by 7 is going to be 8. Correct. Now let's find the standard deviation. I'm going to erase this one on the side so that I can write here for this question. Standard deviation like we did before. This time I promise I'm not going to leave that number. Okay, let's try not to leave the number. Okay, what's the starting points? You got X data here, and let's put the data 7 here, 8 here, 8 here, 8 here, 8 here. Notice here a bunch of the 8 here. Okay, again one, again one more 8 and one more 9. All right, let's see. Did I leave anyone? 1, 2, 1, 2, 3, 4, 5, 6, 7. Okay, good. Now this is the X minus X bar. Let's do the data minus mean. And what I'm doing here is I know X bar is 8. X bar is 8. Therefore, I use 7 minus 8, which is -1. 8 minus 8, which is 0. Notice that 8 minus 8, 0, 0, 0, 0. 9 minus 8, which is 1. Okay. Therefore, you have the deviation. This is called deviation again. And now what you're going to do is square the deviation, X minus X bar, square of that. And this is pretty simple questions because you have everything 0 and 1, not that difficult. What is square here is -1 is square. -1 square is just 1, right? Here, not responding. Wait. -1 square is just 1. Therefore, what I'm gonna having here is 1, 1, 1. Sorry, 1, 0, 0, 0, 0, 0, 1. Because square of this deviation is gonna be this. And finally, you add a sum of all square of the deviation, which is gonna be what? Just 2, right? You add all this square here. Remember, this symbol is sum. Therefore, you adding all this gonna be 2. Okay. What's the formula for standard deviation then? As I told you before, the standard deviation formula is standard deviation equals to, I put SD for standard deviation. Okay, S for standard, D for deviation. What's the formula? Square root of X minus X bar, square of the sum over n minus 1. Notice that this is what goes in the top. Okay, the top inside the square root is square of the deviation, which is going to be 2 divided by what is n minus 1, and is 7 minus 1 square root, and 2 divided by 6 square root. Anybody do the math and tell me what you get? 2 divided by 6 square root. Question number 7. Find the standard deviation for the group of data item. Again, listen, there is a data item here, but in the form of stem leaf. But what are the data item here? Can you find the data here? Yes, you can. Here, the data is 0, 7 is one data. 0, 7 is one data. Pretty much 7 is data. And 1, 4 is another data. 1, 4, 1, 7 is data. Therefore, actually we have a 0, 7 is one data item. 1, 4, 14 another data item. 1, 7, 17 another data item. 2, 4, 24 another data item. 2, 7, 27 another data item. Therefore, you have this data set from this stem leaf plot. Notice that along you have a stem and leaf, you can find the data values. Okay, like this. Stem is first digit, leaf is the second digit. Remember that you have 2 leaves, means 2 data item from that one stem. 1, 4, 1, 7, 2, 4, 2, 7, 0, 7. This is the data we found it from this stem leaf plot. Okay, this is called stem leaf plot. Okay, and from the stem leaf plot, you will find the data item. Now find standard deviation as before. Okay, find the standard deviation as before. Wait, not responding. Standard deviation as we did before. Okay, and you guys finish yourself for the question number 7. Okay, question number 8, and there is a 2 set of data here. The data set give the number of platinum album for 5 male artists and 5 female artists in the country with the most platinum album through a recent year. Complete part A through D below. Part A. Without calculating, which data has the greater mean number of platinum album? Explain your answer. Is the male artist or female artist has greater mean number of platinum album? What do you guys think? Can you look at the data item and tell me which has a greater mean, male artist or female artist? What do you think? Without calculating, don't do the mean. You know how to find the mean, by the way, but without doing mean, how do you which one is has a greater mean? What do you think? Male artist or female? Of course, male artist. Look at the male artist at the data. 142, 98, 81, 74, 67. Look at the female artists. 63, 61, 56, 50, 50, 43. Therefore, even here, smallest data value in the female artist is, in this female artist data value, the biggest number, which is 63, is smaller than the smallest value in this male artist, right? Here, every number here is bigger than over here. Therefore, obviously, male artist has mean greater. What's the answer? Answer is C. Read the question properly. Male artists have the greater mean number of platinum album because all of the data items for the mean are greater than the greatest data item for the woman. You can see that. See, every data item for the male artist is greater than greatest value of the woman data item. Therefore, that's how you know male artists have a greater mean. Now verify your conjecture. Now you guess before, right? In this case, without calculating, you guess it. But next question, verify your conjecture by calculating the mean number of platinum album for each data set. Okay, now you know how to find the mean of male artist. Male artist, what's the mean? ARTIST. Mean gonna be you add all this data item, 142 plus 98 plus 81 plus 74 plus 67 divided by 1, 2, 3, 4, 5, and you'll get if you do add and divide by 5, you get 92.40. That's the male artist mean, 92.40. And how about the female artist mean? You do the same thing. I'm not going to do that. If you find the mean of female artists, X bar, for the female artist, you do exactly the same thing. You add all this data value, divided by 1, 2, 3, 4, 5, you get 54.40. Therefore, for female artist, mean going to be 54.40. 92.40. Make sense? Now, again, next question. Without calculating, I did part A and B. Part C. Without calculating, which data has the greater standard deviation? Explain your answer. What do you guys think? What do you guys think? Which data has a greater standard deviation without calculating? Can you tell me? Which data has a greater standard deviation? Listen. Look at the male artist platinum album. Smallest data is 142. Largest is 67. Sorry, smallest is 67. Largest is 142. Mean is 92.40. And look at it. This is 142 is far from the mean. Okay, watch. For here, mean is how much? 92.40, right? Let's see the mean here. For male artists, the mean is 92.40. 92.40. I'm frozen here. Hold on a second. Okay, this is 92.40. For this female, mean gonna be we found the mean gonna be 54.40. All right. And if you notice here, all the data value 63, 61, 56, 50, 42 are very close to this mean, right? You guys notice here. Okay, every data value in the female artist is very close to the mean. 54.40 is the mean. Every data value are close from the mean. But look at this male artist. 92.40 is what? That's the mean. But look at the other data value. This is very far from the mean. Therefore, the male artist data value are spread all over. Okay. That means this data item are very, very far from the mean as compared to female artist data value. Therefore, the answer is the male artists have the greater standard deviation because there is a greater spread in the data for mean. You guys see that there is a greater spread of the data. Greater spread in the data. But female artist doesn't have that much spread. Okay? Therefore, it has a greater standard deviation. Now, find the standard deviation for each one. Again, I'm not going to do that. Since you have a mean for each artist, you can find the standard deviation just using the idea we had it before. Remember, this way you find the standard deviation of each data set. Okay, that's the question number 8. You can finish yourself. Again, you know how to find the standard deviation. That's the thing. All right, question number 9. By accidentally, it's the kind of same questions, but maybe different number. Let's say here 142.98, but here 140, not 107, but exactly similar question, just different number. I don't know why you have like that, but it's there anyway. If you do number 8, you can do number 9. Okay, let's do number 10, the last one here. Over 1 month period, stock A had a mean daily closing price of 77.6 and a standard deviation of 5.6. That's the mean of the stock A, and that's the standard deviation of stock A. Okay, stock is share you can buy in the market. Standard deviation of stock A, mean of the stock A. Now for stock B, mean is 121.1 and the standard deviation is 12.5. All right, my pen is not responding that well. 12.5. Which stock has more volatile? More volatile is more spread. More volatile, more spread. Okay, that means more standard deviation. More volatile, more standard deviation. Therefore, stock B was more volatile because it has a larger standard deviation. Okay, more this standard deviation, more volatile. Okay, that's all about this section 12.3, measure of dispersion. Thank you for watching the video.